We're going to wrap up 3.3 with doing a couple of proofs. In order to do these proofs, we have to go over converses of all of our different angles, corresponding, alternate interior, alternate exterior, as well as consecutive interior. So in 3.2, we learned that the corresponding angle theorems, which states if you have two parallel lines, then the corresponding angles are congruent to each other. The converse of that is also true. So it's it's reversed. So we're actually starting off with two corresponding angles that are congruent. So if they are congruent to one another, then we can make the conclusion that the two lines are parallel. So it's the opposite. In our angles theorem, corresponding angles theorem, we start with parallel lines to draw the conclusion that the two angles are congruent. In our converse, we start with congruent corresponding angles to conclude that our lines are parallel. So this is a good spot to jot down a few notes. I will be providing this for you, so if you don't want to write them down, it's okay. Or a picture of the screen might be a good idea as well. So we're going to go through this with our other angles. It's going to get a bit repetitive, but hopefully it will help instill the concept. So our alternate interior angles theorem is that if we start off with two parallel lines, then we can conclude that alternate interior angles are congruent to one another. The converse starts off with alternate interior angles being congruent. Therefore, we can conclude that our two lines are parallel. Alternate exterior angle theorem states if we have two parallel lines, we can draw the conclusion that alternate exterior angles are congruent. The converse of that is that we are starting off with alternate exterior angles being congruent. Therefore, our two lines are parallel. And finally, we have consecutive interior angles. So if two lines are parallel to one another and we have a transversal that cuts through, consecutive interior angles are supplementary. The converse starts off by saying that the consecutive interior angles are supplementary. Therefore, we can make the conclusion that our two lines are parallel. So we're going to do two proofs. Our first proof is that we want to prove the alternate interior angles converse. So we want to prove that because 4 and 5 are congruent to one another, G and H are parallel. We can't just say that it's parallel because the alternate interior angles converse, because that's what we're trying to prove. So we're going to start off with our given. So the only thing that we were given was that angle 4 is congruent to angle 5, and the reason for that is given. If you notice, I also marked a separate angle, angle 1, in the diagram. We're going to use that angle because we know that angle 1 is congruent to angle 4. We know that because they are vertical angles. So that is our vertical angles congruence theorem. So if we look at our statements, we have shown that angle 5 is congruent to 4 and angle 1 is congruent to 4. Well, if they're both congruent to the same exact angle, and that angle is 4, then therefore they are congruent to each other. So we can state that that angle 1 is congruent to angle 5. That is our transitive property. So we've now shown that 1 is congruent to 5. If you notice, that is in the top left-hand location of each line. Therefore, we can conclude that G is parallel to H, and that is our corresponding angles converse. In our last proof, we are given that the measure of angle 1 is 100 degrees, and the measure of angle 2 is 80 degrees. And we want to show that the measure, or that line M is parallel to N. So if we're thinking a little bit about this before we go to start, 180, okay, that is 180 degrees, which is supplementary. So we want to go along the lines that 1 and 2 are supplementary angles. Since they are supplementary and they're consecutive interior angles, we're going to want to use our consecutive interior angles converse. All right, but first we have to show that they are supplementary. So I wrote down the measure of angle 1 is 100 degrees. The measure of angle 2 is 80 degrees. The reason is that it's given. So I'm going to restate that if I add together the measures of angle 1 and 2, that'll be the same as adding together the measures of 1 and 2. That is our reflexive property, because the two angles added together equals itself. Now I can do a little bit of substitution, because I know that angle 1 is 100 degrees. I know angle 2 is 80 degrees. So I'm going to substitute in those values. So I'm going to rewrite that as the measure of angle 1 plus a measure of angle 2. Here's my substitution piece. Angle 1 is 100 degrees. Angle 2 is 80 degrees by substitution. I can combine like terms, so I can combine my 100 and my 80 to get 180 degrees, and we just simplify. I can say that angle 1 and angle 2 are supplementary to each other because I just showed that they equal 180 degrees. So that is by our definition of supplementary angles. So since I showed angle 1 and angle 2 is supplementary, I can now state that line M is parallel to N, and that is our consecutive interior angles converse.